Hello guys, in this video I'm going to show you how to solve tree diameter. Given a binary tree, find the length of its diameter. The diameter of a tree is the number of nodes on the longest path between two leaf nodes. The diameter of a tree may or may not pass through the root. Note, you can always assume that there are at least two leaf nodes in the given trees. So, the first example is a binary tree with three levels, as you can see, and we need to find its diameter, right? So diameter is the number of nodes on the longest path between two leaf nodes. So for example, if we consider these two leaf nodes, its path would be the path from node 5 to node 6 would be 5, 3, 6. It would be 3 nodes in total, right? So that's one possibility. So another one would be from 4 to 5. The path would be 4, 2, 1, 3, 5. They are 5 nodes, so which is better than the last one. And 4 to 6, the path would be 4, 2, 1, 3, 6. Also 5 nodes in totals. So that's all the paths that we can find between two leaf nodes. So the best path, the longest path that we can find is at the length of 5. So the diameter of these trees is 5. Right? So it would be a path that goes through the root node. Right? Right. One observations here that we could make is that in this case, the diameter is actually equal to the tree height of left branch and tree height of the height of left branch and the height of right branch, right? So okay, so let's take a look at another example. Okay, for this one we have three leaf nodes, right? So let's say from 2 to 10, for example, it would be this way, has 6 nodes in total, and 2 to 11 also has 6 nodes, right? Both of these parts go through the root node, right? Okay. And okay, so the last path that we can find here is between 10 and 11. This one will go this way and will not go through the root node. And there are total 7 nodes in this part, which is the longest that we can find in this tree. So here is the diameter. The diameter of this tree is 7. Okay. And as you can see, for this one, it doesn't pass through the root node, right? Okay, so So if we consider, let's say, if we consider only this right subtree, right? Then the diameter is again is the height of mm, the maximum height of um, left branch and maximum height of right branch, right? So it seems like we can make a recursive call here to we can make a recursive call here from the root node to uh, its left child and right child. So one observation that we can make here is that uh, the diameter uh, of a tree could be either the diameter of the left or could be either the diameter of the left subtree or the diameter of the right subtree, or it could be in case the diameter go through the root node, it will be equal to uh, the height of left branch and the height of right branch, right? In this case, uh, let's say the right branch had the height of left branch at the height of 2, right branch at the height of 2 also. So it would be plus 1. It would be plus 1 because here we are need to count number of nodes, right? So for example, just modify this tree a little bit. So we have something like this. Then the diameter in this case would be probably from 4 to 7, right? So it would be 1, 2, 3, 4, 5, 6, right? And if we and in this case the diameter would be the height of the left tree, um, the left branch plus the height of the right branch. It would be 2 here and 3 here. The height is actually the depth, right? The longest part from root to leaf. In this case, it would be on the right branch. It would be all the way from 1 to 7. It would be three nodes, right? And in this case, it would be 2. So 2 plus 3 is 5, and plus 1 here would be 6. right? But in this example, okay, let's write down the diameter could be either um, left height uh, plus right height plus one, right? In this case, for example, in this case, left height is one, right height is four, right? 4 plus 1 is 5, plus 1 here is 6, right? Or uh, left diameter or right diameter. Again, uh, here is the diameter of one node of the root node, right? And for example, the right diameter is when we consider the root node as 3, right? So at node 3, we again asking the same questions, right? Like for example, in this case, the left height is 3, the right height is 3, plus 1 is 7, right? The left diameter is when we consider 5 is a root node. Okay. Okay. So let's code it down. Uh, okay, here is a formula, right? Uh, to find the diameter of the root node, right? Mm, so, like at the original functions here, we don't know the left height yet, right height yet. We don't know left diameter yet. We don't know right diameter yet. So we need to delegate the questions to each child, right? So probably okay. So for each recursive call, like for example, here's the root node, right? When I delegate the questions to let when I delegate the questions to lab sub tree, what information do we need? Here is a lab height and lab diameter, right? Mm, okay. So for each uh, recursive call, here's the two piece of informations that I need: lab height and lab diameter. Mm, so because these functions, the original functions is the one that I need to return the diameter only. So um, one way I could get around these issues is find diameter. I will define a functions inside this one, inside the original functions, and here will be root. Okay, this recursive functions call must return two pieces of information, which is height, and it could be something, and its diameter. Dot dot dot. Don't know yet, but here is the two pieces of information. So, and down here I will make the first function call, right? Passing in the root node. Root here, I call these functions. I pass the root from outside to these functions. Okay, and the return here is actually these objects. So what I need here is a diameter only. Okay. Okay, inside here I need to find height and diameter of this root. So the height of a node is, let's say for example here, I need to call it recursively until it reaches the leaf node, right? And probably at each level I will need, when I go down one level, I will need to um, increase the height by 1. So the height of the tree will be the like for example in this guy, it will be the maximum height of the left or right and right, left and right. Like for example here, the left is 2 and the right here is 5. So in this guy it would be, I will take this one at the height. So here I will need to call it recursively with the left subtrees and right subtrees. Find diameter, passing in the root of left, and yeah, and also root of right. And this one will return height and diameter. This one also. But it's the same variable name here, so I will rename it into hey lab hey, because here we are finding uh, we consider the lab the lab child. Here the diameter lab diameter. Okay, here the right and right diameter. Okay, the height here will be uh, the height of the root node will be 1 plus, like for example here the left is 1, the height is 1, and the right the height is 4. We will take 4 because it's longer, and plus 1 because when we consider the root we need to add 1 to the height, so it will be max of left height and right height. Okay, diameter. Okay, as we discussed earlier, the diameter of a root could be either one of these values, and we would take the one that is largest. And because we call it recursively, so probably we want to stop somewhere, right? Probably when root eno returns 0. So here, for example, okay, the first function's call the root is 1. It will go to the left first, right? Okay, so here it goes to the left and we know, go to the right we know. No, it will not be 0, but instead if it's no here we need to obey this form, which is hey. If the AVG that is no and the height is 0, probably the diameter will be 0 also. Okay, so for node 2, so when we go down to node 2, the left will be 0, the line 0. So node 2 will be 1 plus left 0, right 0. So the height is 1. The diameter will be 0, 0, and here is 1. The diameter here is 1. Not sure. Let's run the test. Just 8 and 6. Whoops, it doesn't work. Because probably here we assume that there are two leaf nodes in the tree, so probably gonna stop when uh, when we reaches the leaf node probably. So when we don't have left and we don't have right, then the height of this will be 1. Right, the diameter will be probably 0. Okay, let's run the test. Still okay. What is wrong here? The diameter is I think this should be fine. The height will return is 0, diameter is 0. What's wrong here? This will return an object. What's in the foot? And exact the diameter here. I know, missing the return. Okay, silly mistake. So that is it for this video. Anyway, I find this one is pretty difficult to explain. Maybe I will make another video on this one later. So anyways, thanks for watching. See you in the next video.